Hello students, today we learn the Lorentz equation. We know that the charged particle can be present in an electric field plus in the magnetic field, and both can be act force on this particle. Force due to the electric field can be represented by the F is equal to Q by E, where E is the electric field and force due to the magnetic field is represented by the F is equal to QV plus V, where V is the velocity of the moving charge and B is a flux density. If we combine both force on charge Q due to the electric field and due to the magnetic field, then that force can be considered as a Lorentz force, and the equation due to the combined force is known as the Lorentz equation, which is given F is equal to Q E plus V cross B. Okay, we try to understand the Lorentz force due to the examples. Okay, here we have given the one charge 10 nanocoulomb is moved in the velocity with the velocity 10 raised to 7 in a bracket minus 0.5 ax plus ay minus 0.71 az in meter per second, and we determine the force exerted when the magnetic induction B is ax plus 2ay plus 3az meter Weber per meter square, and electric field E 3ax plus 2ay plus az kilovolt per meter, and due to the both magnetic induction and the electric field E. Okay, here we have given the charge Q, which is the 10 nanocoulomb, so it can be represented 10 cross 10 raised to minus 9 coulomb. Velocity V, which is given by the 10 raised to 7 in bracket minus 0.5 ax plus ay minus 0.71 az meter per second. Magnetic induction B, which is the ax plus 2ay plus 3az meter Weber per meter milli Weber per meter square, and the electric field intensity E, which is the 3ax plus 2ay plus az kilovolt per meter, so it can be represented by the 10 raised to 3ax plus 2ay plus az volt per meter. Okay, first of all we find the magnetic force Fm due to the B. So we know that the magnetic force due to the Fm can be represented by the QV cross B. Here Q is the scalar quantity, V is the velocity, which is the vector, and the B is the magnetic field, which is the vector. So first of all we try to find out the cross product of the V cross B. So we put the value of the Q, which is the 10 cross 10 raised to minus 9, velocity, which is the 10 raised to 7 minus 0.5 ax plus ay minus 0.71 az direction cross B vector, which is the ax plus 2ay plus 3az. First of all we multiply the scalar quantity here, so we get 10 raised to 7 into 10 raised to 1 means 10 raised to 8 minus 9, so we get the 10 raised to minus 1, and the cross product of the 2 vector, which is the 0.5 ax plus ay minus 0.71 az cross ax plus 2ay plus 3az. Now 10 raised to minus 1 x component, ay component and az component of the velocity v and component of the magnetic field 1, 2 and 3. If we solve this, we get 10 raised to minus 1 4.42 ax plus 0.79 in ay direction plus minus 2ay 2az direction. For solving, first of all, we here take the ax multiply by 3 minus 1.41 minus 1.5 for the ay minus 0.71 ay plus az minus 1.0 minus 1, say 1. Now magnitude due to the force so we can say that 10 raised to minus 1 under root 4.42 square plus 0.79 square plus minus 2 square. If we solve them, we get total force for 0.49 Newton. Now we find the force due to electric field E, which can be represented by the F E is equal to QE. So 10 cross 10 raised to minus 9 3ax plus 2ay plus az cross 10 raised to 3. So we get 10 raised to 9 means 10 raised to 4 cross 10 raised to minus 9 3ax plus 2ay plus az. So we get 10 raised to minus 5 3ax plus 2ay plus az, or we can say that 30ax plus 20ay plus 10az micronewton. If we combine, say equation number 2, if we combine equation 1 and 2, force Fm plus Fe, force due to the Fm is 0.49 plus 30ax plus 20ay plus 10az we get total force or Lorentz